We are the paradoxical ape. Bipedal, naked, large-brained, long the master of fire, tools and language, but still trying to understand ourselves. Aware that death is inevitable, yet filled with optimism. We grow up slowly. We hand down knowledge. We empathize and deceive. We shape the future from our shared understanding of the past. CARTA brings together experts from diverse disciplines to exchange insights on who we are and how we got here. An exploration made possible by the generosity of humans like you.
I'd like to start by acknowledging that I'm speaking to you today from the lands of the Kaurna people of the Adelaide Plains and acknowledge their elders past and present. I'd also like to extend my respect to the traditional custodians of all of the lands that the audience is joining us from today. So my topic today is accumulating space debris and the risk of Kessler Syndrome. I'd like to start just by putting the Earth into the context of the entire solar system. And in this image here, you can see the Earth on the far left corner, the third planet from the sun. The red label of Voyager 1 is the approximate location of the Voyager 1 spacecraft now in interstellar space, which is the furthest human object away from the Earth. And then you can see a slice through the Oort cloud, which is a huge sphere of icy and rocky bodies that surrounds the entire solar system. So this is our geographic context, if you like. Now let's focus in on the Earth itself. This is an image of space junk surrounding Earth, in which you can see a close cloud in low Earth orbit of little white dots, each one representing a satellite or a piece of space junk, and a broad ring, which represents the geostationary orbit where most of our telecommunications satellites are up until the launch of the mega constellations. So it's estimated that in this assemblage of space junk, there are approximately 34,000 pieces of debris that are larger than 10 centimeters. And below 10 centimeters, millions and millions and millions of little bits of junk going right down to the microparticulate or the nanoparticle size. In weight, the total of this debris surrounding Earth is equivalent to 10 million cane toads. Cane toads are a pest that was introduced into Australia in the 1930s to control other pests on sugarcane crops, but quickly became a problem in its own right. And it's currently destroying wildlife and spreading itself throughout different Australian states. So it seems like a good metaphor to me for the problem of space junk, which is proliferating and increasing every year and putting human operations in space at risk. So we talk about space junk as if it's all one kind of thing, but in actual fact, what we call space junk is made up of a number of specific classes of objects. And of these, perhaps the most recognizable are defunct satellites. Satellites that were once used for Earth observation or telecommunications that have ceased to work or have been damaged in some way. Then we have upper rocket stages. These delivered these satellites into Earth orbit and have been abandoned there. There are hundreds and hundreds and hundreds of these, very unstable at risk of explosion. There's also mission-related debris. These are all of the things that get left in Earth orbit in the process of deploying a spacecraft and the fairings that enclose the spacecraft or satellite before its release are among those mission-related debris. And then, of course, we have fragments that come from explosions or collisions or damage to spacecraft. And it's not randomly distributed, as we saw in our first picture. There are a number of high-density orbits. Low Earth orbit is the most dense. We have a more or less equatorial circular orbit. There's also polar orbit in this region. About 35,000 kilometers away from Earth, we have the all-important geostationary or geosynchronous orbit, where the telecommunications satellites and also China's navigation constellation are located. There's a number of others as well. The Molniya orbit was used by the former Soviet Union because its highly elliptical shape enables satellites to reach high latitudes. There's also the graveyard orbit. So about 500 kilometers beyond geostationary, old satellites often get boosted up out of the way. So this is the physical structure of the debris that surrounds the Earth. And the problem with it is that each one of these objects on average travels at 8 kilometers a second. So if you collide with something traveling at that speed, there are going to be consequences for this. If two large objects, and by that I mean over 10 centimeters, it doesn't seem that large, but in space terms it is, if they collide, then each of those objects is likely to catastrophically break up, producing hundreds or thousands of new pieces of debris. For the smaller size, which is between 10 centimeters and 1 centimeter, collision with one of these can possibly cause the satellite to stop working or cause damage to electronic components. And occasionally there might be an explosion. And the tiny, tiny, tiny little pieces are just constantly bombarding every object in space. So there's an accumulation of material degradation over time. So this is the problem with space junk. It creates more space junk, and each dead object in space is a risk for those functioning satellites that we rely on so much in the modern world. Back in 1978, two space scientists, Donald Kessler and Burton Coulpillet, wrote a very famous paper in which they discussed the possibility that space junk could form actual rings around the Earth. This became known as Kessler Syndrome. And the popular conception is that enough space junk is created that it actually encircles Earth and means it would be impossible to leave without being struck by these incredibly fast-moving bits of junk. They didn't actually predict this in their paper. They said certain regions of Earth's orbit might become unusable. But in either scenario, this is considered highly undesirable. This is something that could seriously hamper human activities in space. And it's a problem that we're not anywhere near close to solving at the moment. We keep putting more stuff up there and more debris keeps being created. So this is widely acknowledged to be a big problem. But what I want to do today is actually look at space junk from a few different perspectives. So as well as a problem for future space industry, we can look on all of this stuff as a new kind of archaeological record. And what I'm showing you here is a little snapshot of the year 1961. So that's just 4 years after the launch of Sputnik 1, the first satellite ever to reach Earth orbit. There were 30 objects launched into space this year, and 9 of these survive, and they include some very interesting spacecraft. One of my personal favorites is Track, which you see in the upper range of pictures. This spacecraft had the first poem ever in space inscribed on one of its internal instrument panels. It was also put out of commission by the Starfish Prime high altitude nuclear test. So it forms part of that history of nuclear proliferation and control on Earth. It has a story to tell about how we get to where we are right now. The other one that I find particularly interesting is the Westford spacecraft that you see in the lower corner. This was designed to release tiny electric dipole antennas that would surround the Earth in another kind of cloud to bounce radio waves off. This would have been an efficient method of communication on Earth, but had the effect, if radio waves were confined to Earth bouncing around this ring, it meant radio waves couldn't reach us from the rest of the universe. So radio astronomy was effectively dead. There was a massive scientific campaign and they were successful in getting the Westford project stopped. So this represents a trajectory of technology that did not go anywhere. So this space junk, as well as being dangerous, has cultural values of all different kinds, as we can see from this. Following on from that, we can also look at debris in Earth orbit as a cultural landscape. In the operational guidelines to the World Heritage Convention, a cultural landscape is defined as the combined works of nature and humans. And this is effectively what we've created in Earth orbit now. We have an environment which is a combination of naturally occurring micrometeoroids, radiation, electromagnetic formations, plasma clouds, all kinds of things that we call space weather, with the introduced artificial bodies that are the result of human endeavors in space. So this effectively means it's a cultural landscape, but it's also one that we can't perceive. So a hyperobject, a concept that originates with the ecological philosopher Timothy Morton, is something that is massively distributed in space and time. So no one image or one measurement will tell you what this is. You only perceive it by its effects. And all of this stuff in Earth orbit, I think, fulfills the criterion for being a hyperobject. We see its effects. We can perceive little tiny bits of it if we focus our Earth-based instruments or our space telescopes on it. But the stuff is so widely spaced, really, that we can't ever get, we have to rely on artists' impressions and simulations to get any sense of what's actually happening out there. So we can think of this as a hyperobject, and we can also think of it as an environment. So there's a long tradition of regarding space as a vacuum. There's nothing alive there that we haven't put there ourselves. We're so used to thinking of environments on Earth as being made up of ecologies, of connected webs of living things, from microbes and bacteria all the way up to humans. So space hasn't really been thought of in this way before. And this leads to a situation where environmental management protocols such as we use on Earth are not thought to be applicable to space, and that we have no moral obligation to protect the space environment. So I think looking at space junk as part of an environment gives us a different perspective on how we might manage whatever environmental or cultural values we assess it to have. Everything in Earth orbit is created by a process which is a very Anthropocene process. It's about the redistribution of elements on Earth. And we see this already in the concern for carbon footprints, the changing balance and location of hydrogen, nitrogen, oxygen, and carbon in the Earth's atmosphere. And we're extending that now beyond the atmosphere. So if you rearrange the periodic table not by atomic number, but by abundance in the Earth, you get what you see in the picture down the bottom. It turns out that the most abundant elements are hydrogen, carbon, oxygen, and nitrogen. And you'll also see aluminium is up there. So approximately 1/3 of the Earth's crust is aluminium. Aluminium is also one of the most commonly used spacecraft materials, but it doesn't occur naturally in the open interplanetary space environment. So humans have been sending aluminium into space and beyond to the other planets and moons as well. So we're kind of altering the natural distribution of these elements and minerals by putting them out into space. And we see this in the stuff that's in Earth orbit, but we're also starting to engage in more serious activities of redistributing the elements of the solar system. Soon there are going to be people on the moon extracting its resources. So off-Earth mining is a huge topic in the space community at the moment. So in the way we've started dismantling the Earth in order to get into space, we're soon going to be starting the process of dismantling other moons and planets. And if we take this to its most logical and perhaps bizarre end of the trajectory, what you get is an object called the Matryoshka brain, which was conceived by Robert Bradbury about 20 years ago. The Matryoshka brain is a huge supercomputing object which is manufactured or created by dismantling all of the planets and moons in a solar system, which are then used to create shells of computronium, layers of computing elements, so that the entire solar system becomes a massive computer, whose thought processes work so slowly that humans effectively can't communicate with it. So this is science fiction of the far future, but you could say we're starting to see the beginnings of such a process right now, as we take bits of Earth and redistribute them in space, and as we're thinking about doing exactly the same thing to the moon. The search for extraterrestrial intelligence, also known as SETI, is dedicated to looking for evidence of other intelligent or sentient inhabitants of the universe. And exactly one of the things that they're looking for are technostructures or technological objects that can reveal the presence of this kind of thought. Except with our limited capacity to view things from Earth, we need to look at them as giant engineering projects in space. So there are instruments on Earth all of the time looking at exoplanets, wondering if they might see such a signature. And of course, in space junk, we have created this signature for our own planet. We're creating potential rings around Earth, just like we see around the planets from the middle to the end of the solar system. Most of them actually do have ring structures. The inner planets don't, but we're kind of making our own. So with space junk, we're creating exactly the kind of technological signature that SETI scientists are looking for in other planets. Whether this does end up making us more visible to anyone looking from the outside is a whole other question. But this is another way we can look at the accumulation of debris in Earth orbit. So what happens if we do reach the tipping point and end up with Kessler Syndrome? So there's no broad agreement about when this might happen or if it might happen at all. Some people say with another anti-satellite missile test, as we saw from Russia last year, that could be the tipping point. We would get this endless cascade of collisions and we would never reduce the amount of space junk in Earth orbit. Other people say we're never going to get to that point and there's so many people working on the problem of solving space debris. But let's just say the tipping point is reached and it's not so easy for us to leave Earth anymore. What is this going to mean? A lot of discussion around space activity is based on this idea that it's in our genes, that humans as a species are evolutionarily adapted to exploring, and this is a natural outcome of something that began deep in the Paleolithic era. So conceptually, if this possibility is closed off, some people argue that this would be some kind of blow to the human spirit that it would be difficult to recover from. I think it's worth mentioning here that when we talk about humanity in space, it's not everybody who gets to go to space. It's not everybody that has created the space junk problem. The bulk of space junk in Earth orbit comes from Russia, former Soviet Union, the US, and China. So when we talk about humanity at this scale, we have to ask ourselves exactly who are these humans and what are the different impacts on them. So maybe making statements about the future of humanity's evolution is a bit much at this point. One thing would be certain: if it were difficult to leave the Earth, this would be perhaps dramatic end to capitalist expectations about how space will be used and exploited. And this is the dominant paradigm of looking at space at the moment in the international space community. So the idea that space is a resource for humans to use rather than any of the other ways of looking at it that I've outlined here is extremely commonly accepted and is becoming more acceptable. And this is the way future space industry is going to be going. So this one view, which arises from a particular historic point in time and space, is now becoming the globally accepted way of looking at our engagement with space. So if Kessler Syndrome stops us from getting off the planet, that means space is safe from this kind of exploitation. So what will that mean? As an archaeologist, it strikes me also that Kessler Syndrome could cause what is a big area of study across the archaeological record in many continents, and that is the collapse of civilization. And again, we have to say, well, what does civilization mean in this context? What does it mean for it to collapse? What will that look like in the archaeological record? And I suppose from the perspective of space, what that will look like is a ring of debris around the Earth that decays over time, breaks into smaller fragments, in which the outside observer would see that there were no new objects being placed, and that it was gradually coalescing into one big structure that perhaps from a distance might be indistinguishable from a natural planetary ring. I will leave it there. Thank you very much for listening.